Okay, good morning, children. Today we'll learn new topic. In maths paper 1B, you have two parts. One is coordinate geometry, other one is calculus. Now, what is this calculus? This calculus is a new branch which you are going to learn, and then it deals with the geometric problems. It originated to solve the geometric problems. Now, this calculus is divided into two branches: differential calculus and integral calculus. Now, differential calculus, you learn the basic things. In intermediate level, you learn the fundamentals of differential calculus and integral calculus. In first year, you learn differential calculus, and in second year, you learn about this integral calculus. You are learning the fundamentals. And then when these fundamentals you should understand properly, then only you will be able to understand the higher things. Okay. Now we'll start this differential calculus. In calculus, first basic thing is limits and continuity. The chapter name is limits and continuity, but continuity is at present for this academic year it is deleted. Now what is this limits? Before learning about this limits, we'll learn something called as intervals. What is this interval? Okay, now you consider a real number line. Consider a real number line. Suppose that I have a number 1 here and a number 2. Between 1 and 2, can you say how many real numbers are there between 1 and 2? At least after 1, can you say what is the next real number? You cannot say. It can be 1.0001. We cannot say the exact number after 1. So all real numbers lying between 1 and 2. The set of all x is a real number. Set of all x is a real number such that x lies between 1 and 2. X lies between 1 and 2. This is denoted by the interval. We denote this by 1, 2 like this. It is an ordered pair, but here it is a set ordered pair. Like see, you have come across this ordered pair of numbers in coordinate geometry also, x-axis, y-axis. So suppose I have this 1 and 2 here. You denote this point, coordinates of this point by 1, 2, isn't it? So this is an ordered pair. This is a point here. This represents a point. 1, 2 here represents a point. Now here 1, 2 is called as here, it is equal to. X lies between 1 and 2, or x is a real number and x is equal to 1, x is also equal to 2. In that case, I should write closed brackets. These are called as closed brackets. So closed interval 1, 2 means all real numbers lying between 1 and 2. It is an infinite set. Now suppose I write open brackets like this. Then it is set of all x such that x is a real number and 1 is less than x is less than 2. That means 1 and 2 are not there, but all numbers after 1 we don't know what the number is. So all real numbers lying between 1 and 2 are in this set. Now this is an open interval. If you include 1 and 2, then you must write closed brackets. If you are including 1 and 2, then you have to write the closed brackets. So these are intervals. This is an interval. Here it is a point. Understand the difference. Okay, now suppose that I need all the real numbers which are greater than 2. That means it is from 2 to infinity. Then we write like this. If I include 2, we should write closed brackets. 2 to infinity. Infinity side we should always write open brackets. So this is the set of all real numbers such that x is greater than 2. X is greater than or equal to 2 because you are writing closed brackets. Suppose I write to infinity like this. Then it is the set of all real numbers such that x is greater than 2. 2 is not included, but the next real number. From there onwards to infinity, all real numbers are there in this set. So all these intervals are infinite sets. These are called as intervals and they are all infinite sets. Now suppose I have to write all the real numbers less than 2. Then it is minus infinity to 2. If I include 2, then I should write closed brackets and it is again set of all x belongs to R such that x is less than or equal to 2. x is less than or equal to 2. Now suppose I don't include 2, then it is minus infinity comma 2, that is set of all x belongs to or x is a real number such that x is less than 2, like this. So when you put open brackets, that particular number is not included. When you put closed brackets, that number is included. Greater than or equal to 2, like this. 2 to infinity, x greater than 2, x lying between 1 and 2, like that. So here we took an example taking the number as 2. So in general, if you have a comma b, a should be always less than b. Here first number should be always less than second number. A should be less than b. So this interval is equal to the set of all x. X is a real number such that x lies between a and b. So here I am putting open brackets, so a and b are not included. If I put closed brackets, then I should write equal to here. In the same way, you can write any set of all real numbers greater than a. Greater than a means I should write a to infinity, like that. So this is all about the intervals. Now in this calculus, we come across these symbols. This is called as epsilon and this is called as delta. These are very small positive numbers. Very small positive numbers like 0.001, 0.101, like that. They take very small values. Okay, now we define another term. So intervals is over. Now we define another term called as neighborhood. N-E-I-G. Called as another term, that is neighborhood. Delta neighborhood or epsilon neighborhood. Delta neighborhood of a point A. Delta neighborhood of a point A. So what is this delta neighborhood? Suppose that I have a point 2. Okay, we'll take the same number 2. Now we'll take one small interval around 2. On the left side, right side, we take epsilon or delta neighborhood. So that means 2 minus delta and then 2 plus delta. This number is 2 minus delta and this value is 2 plus delta. So 2 minus delta, 2 plus this delta. This interval is called as the delta neighborhood of the point A. So delta, what is delta? Delta is a very small number. So that means it is 2, suppose delta is 0.01. Then this will be some 1.99 and then 2.01. So you can see this is the delta neighborhood. When I add yes, this is the delta neighborhood of A. This interval is 0.01 neighborhood of the point 2. Here I took the number as 2 now, so it is this. So this small interval is called as the delta neighborhood of the point 2, of the point A in general. Now suppose that in this interval, all numbers lying between 1.99 and 2.01 are there. Now suppose that I delete the number 2, except 2, all numbers between 1.99 and 2.01 are included in this set. Then this set is called as the deleted neighborhood of 2. Deleted neighborhood of 2. In general, A minus delta, A plus delta is called as the delta neighborhood of the point A. This is called as the delta neighborhood of the point A. And then deleted neighborhood of the point A is A minus delta, A plus delta minus the element A. So this is a new term. So we learned about these intervals. Then epsilon, delta, these are the terms, these are Greek symbols. And then delta neighborhood of the point A. And then deleted neighborhood of the point A. Okay, now we'll write the definitions later. First understand these terms. These are all new terms to you. So these are frequently used when you go to higher classes. These terms are frequently used in those topics. So you should understand these terms. Okay, next in functions chapter, you learn many kinds of functions. F of x, like see, you have y is equal to f of x, y is equal to some 2x plus 3 or x square plus 1. Suppose you have an equation like this. You have drawn graphs of all these functions, isn't it? So we take, instead of x square, y we take as f of x. Then f of x is equal to x square plus 1 is a function. So you will learn more about these functions in the functions chapter. At present we need these terms, so we are just having the gist of it. So f of x is equal to, suppose I have some a naught x to the power n plus a1 x to the power n minus 1 plus so on a n x to the power n. This is the general one. A naught, a1, an are all real numbers. Then this is called as the polynomial function. It is called as the polynomial function. F of x is equal to, where here n is a natural number. N is a natural number. And then these powers, they should, n is a natural number, and all these powers should be integers only. They cannot be fractions. They cannot be fractions or negative numbers also. They should be positive real numbers, all these powers. That is polynomial function. Next, algebraic function. Algebraic function is if you have f of x in the form, I'll give examples, x square plus 3x plus 4 by some x cube plus 3, like this. This is an algebraic function. This is a polynomial and this is also a polynomial. It contains all, it can be multiplication or division of polynomials. That is the algebraic function. Next, you have trigonometric function. Suppose I have some tan x plus secant x like this. This is a function containing trigonometric ratios, trigonometric functions. That is called as a trigonometric function. Next, exponential function. Exponential function is a to the power x, where a is a positive number. Where a is a positive number, like 2 to the power x, 3 to the power x, some 2.5 to the power x, like that. So this function is called as the exponential function. It is called as exponential function. Okay. Now, exponential function. We have an irrational number e, like you have pi. Pi you take as an irrational number which is approximately equal to 22/7. We have another irrational number which is actually 1 plus 1 by 1 factorial plus 1 by 2 factorial plus so on to infinity. This series, which is approximately equal to some 2.7 like this. So this is an irrational number. We generally denote this series by e power 1 or e. So e is an irrational number. So e to the power x is another exponential function that we come across in this chapter. E power x is an exponential function. Okay, next is logarithmic function. Suppose I have f of x as log of some 3x or 3x square plus 4x plus some 1, like this. So this is a logarithmic function. In calculus, wherever you come across logarithmic function like this, the base will not be mentioned. It means that the base should be taken as e. As far as calculus is concerned, the base of the logarithm should be taken as e. If it is not e, if it is something else as 10 or something else, it will be mentioned in the problem or wherever it is. So in calculus, if base of the logarithm is not mentioned, then it is understood that it is e, where e is the irrational number, which I explained just now. Okay, next is very important function. You will learn all about this in functions chapter. So in finding the limits, we need all these type of functions. So next one is modulus function. What is this modulus function? So you already know what is, suppose I write mod of minus 2. Mod of minus 2, you say it as 2. Mod of minus 2 is 2. Or mod of 3, you say it as 3. Positive value. You take the absolute value of that number. Absolute value of that number. Now the actual definition is like this. F of x is equal to mod x. F of x is equal to mod x, where mod x value is x. Is x if x is greater than 0. and it is equal to 0 if x is equal to 0. Mod x is equal to x if x is greater than 0, and it is equal to 0 when x is equal to 0, and it is equal to minus x if x is less than 0. It is equal to minus x if x is less than 0. You may be thinking why mod x is equal to minus x when x is negative. You have already seen this. You already know that, right? Simplifying, writing the value of mod of minus 2 as 2. But see, according to the definition, it is negative. Inside it is negative. X is negative. X is negative. So what should I write? Minus of x. What is x here? Minus 2. Minus of minus 2 is 2. So actually you are using the definition without having the proper knowledge of it. Now this is the definition. You understand the definition, learn the definition. So whenever you have mod x, you should always use this definition and remove the modulus sign. Like and then you should simplify and write the function value. So this is the definition of modulus function. I'll write the summary points first. Try to understand. Okay, next is step function. Next is step function or greatest integer function. Step function. This is again very important. We need it in 2-3 problems. This modulus function, step function, we need in some 3-4 problems. So I'll write the definition. You can understand. A step function or greatest integer function. Step function or greatest integer function, or it is also called as bracket function. It is also called as bracket function. So what is this step function? We write like this, step x. So this is f of x is equal to step x, bracket x, which is equal to where bracket x is equal to the greatest integer. It is the greatest integer less than or equal to x. So what does it mean? Greatest integer less than or equal to x. Now suppose that I have 1.2. Then what is the greatest integer less than 1.2? When you take the real number line, 1.2 will be somewhere here. So greatest integer less than this number is 1. So I should write 1. Now suppose I take 1.999. Then also it is here. 1.999 is less than 2 only. So what is the greatest integer less than this number? It is again 1. It is again equal to 1. So for again, now what is the what is the bracket value of 1? That is 1 only, because the greatest integer less than or equal to x. X is x. So in general, when it is any integer, bracket x is that integer only. When it is a fraction number like this, then you should think what is the greatest integer less than that number, and then you will write that value. Now suppose I have negative number. What is okay, bracket of minus 2 is minus 2 only. When it is integer, you will write the integer value only. But when it is a fraction again, like minus 2.93. So where is this minus 2.93? When I take the real number line, suppose this is minus 2 and this is minus 3 and then minus 1. So where is minus 2.93, minus 2, minus 2.1, 2.2 like this? Here somewhere you will have minus 2.93. So here it is minus 2.93. So what is the greatest integer less than this number? Less than this number is minus 3. So I should write minus 3. You can think like this and then write the value. So this is how the greatest integer function is defined. Greatest integer function or step function is defined. Now we'll learn about these real numbers. Suppose I have 0 into 5. 0 into 5 is 0. You know this. Now suppose I have 0 into minus 5. That is also 0. Now suppose I have 3 by 0. Suppose I have 3 by 0. It is plus infinity. Infinity is a very large number. Infinity is a very large number which cannot be defined. So we write 3 by 0 as infinity. Suppose I have, okay. Now suppose I have okay, 0 by 2. 0 by 2 is again 0. 0 by 2 is 0. Next, suppose I have 2 into infinity. Any number into infinity. Any number into infinity is infinity. Suppose I write minus 2 into infinity. This is minus infinity. Negative number into infinity is minus infinity. Positive number into infinity is infinity. So these are some clarifications which you should understand. Now, okay, now 3 by infinity. Suppose I have 3 by infinity. It is a finite number by a very large number is equal to 0. Again, suppose I have 3 by minus infinity. That is also equal to 0. When you divide a finite number by infinity, it is 0. And then next, now suppose you have 0 by 0. 0 by 0 is indeterminate. 0 by 0 is indeterminate. There are some indeterminate forms: 0 by 0, infinity by infinity, infinity minus infinity. These values cannot be determined. One logical explanation I can give is like this. Suppose I have 0. You may say 0 and 0 get cancelled and it is 1, like that. So it is not like that. Suppose I have 0 into 1. 0 into 1 is 0 only. Okay. Now if 0 into 3 is also 0. So if I divide like this, you may think these two gets cancelled and 1 by 3. 1 by you may say it as 1 by 3. But suppose I write 0 into, I can also write 0 as 0 into 3. 0 into any number I can take. 0 into 4 I take. I can take another 0 as 0 into 9. Then I'll say this 0 by 0 I can write as this by this, and I may say these two get cancelled 4 by 9. So once I may say 1 by 3 and once I may say 4 by 9, like that. Is it possible? When you divide anything, it should be unique. So 0 by 0 is indeterminate. One simple logical explanation I can give like this. So in general, these are indeterminate forms. 0 by 0, infinity by infinity. There are many more forms, but you will come across this indeterminate forms in limits chapter. Okay, next we'll define this limits. Okay, so we studied about what is it that we studied? We studied about intervals. Delta neighborhood, and then delta neighborhood, deleted neighborhood. We studied about the deleted neighborhood, and then these different functions: modulus function, step function, and then these properties, and then indeterminate forms. Now we'll come to the definition of this limits. First we'll consider, suppose that f of x is equal to x plus 3. Now we'll take x values, f of x values like this: 1.99, 4.99, and then 1.999, 4.999, and then at 2 it is 5. When you put x as 2, it is 5. When you put x as 1.999, it is 3 plus 1, 4.999, like this. Now suppose I take 2.01, then it is 5.01, and then if I take 2.0001 like this, then it is 5.0001. Now we'll take this table. Now if you see we have x value as 2. Now we'll take some values less than 2. So we say that x is tending to 2. X is approaching 2 from left side of 2. Left side of 2 means these numbers 1.99, 1.9, like that. The values very nearer to 2, but less than 2. The values which are very nearer to 2 and less than 2 are the left side values of 2. We say that x values which are less than 2 and very nearer to 2 are left side values of 2. So when it is 1.99, it is like this. So from the left side values, this function is approaching what number? It is approaching 5. Now if you take some numbers greater than 2 but very nearer to 2, very nearer to 2, like 2.001, it is very nearer to 2. F of x is taking a value which is very nearer to 5. As x approaches 2, as x comes nearer to 2 with values greater than 2, slightly greater than 2, f of x is taking the value 5. F of x is taking the value 5. So we say that limit, we write like this, limit x tending to 2, as x approaches 2, limit x tending to 2 of f of x is equal to 5. Limit x tending to 2 of f of x is equal to 5. So this is the idea, concept of limits. This is the concept of limits. Okay, now when the difference, the actual definition is like this. When the difference between x, when the difference between x and a, this is your a, and the difference between x and a is made small, the difference between f of x and this is called as L. So the difference between f of x and L is also made small. When you see the difference between 2 and 1.999, it is small. So the difference between these two is also made small. So we say like this. So limit x tending to a of f of x is equal to L whenever this x minus a is less than some epsilon, implies that modulus of f of x minus L is less than delta. So whenever, for every epsilon greater than 0, there exists some delta greater than 0, such that whenever mod x minus a is less than epsilon, modulus of f of x minus L will be less than delta. The difference will be less than delta. So this is the actual definition of limit. We'll write all these things. Now it is getting over, time is getting over. So just we have the basic things explanation. Next period I'll make you write all these points. Now when x approaches a from the left side values, we write like this, limit x tending to a minus of f of x. And when x approaches a from the right side, we write limit x tending to a plus of f of x. So like this we write. So what all we have learnt, we'll write down. This intervals, as I said, all real numbers, set of all real numbers lying between a and b. I took the general letters a, b. A is always less than b, so first element should be always less than second element. Then we have Greek letter epsilon delta, and then delta neighborhood is called this interval. This open interval is called as the delta neighborhood. And then deleted neighborhood means you must delete the number a. Delete the number a. And then these are some of the examples where we come across this type of numbers in limits. So to have some clarification, I just took some examples. And then these are called as indeterminate forms. Like I said, these cannot be determined. These are indeterminate forms. Some more are there, but you have only these forms in your syllabus. Now this is modulus function. Modulus function, mod x is x if x is greater than or equal to 0, and it is equal to minus x if x is less than 0. When x is negative, you must write minus x. So this is very important. We have many problems based on modulus function and 2-3 problems on step function. As I said, it is the greatest integer less than or equal to x. So if this is integer, then the value is integer itself. If it is a fraction, if it is a decimal number like this, then you have to see what is the greatest integer less than that number. So that value you should take and simplify the function. So in the next period, we'll learn about, the limits, left hand limit, right hand limit. And then when is this possible? When left hand limit and right hand limit both are equal, then only we can find the limit. and then the procedure to find the limits. When we get indeterminate form, then what should be done? What are the different methods that we use in finding the limit value? So we'll continue in the next period.